Hello and welcome to Chemistry of Life. Today, these are the things that we're going to cover. We're going to look at the nature of matter, atoms, and chemical bonding. It looks like we're going to do a whole lot more, but time-wise, we're really not. So we will cover these other areas in our next video. Yay! All right, let's start with the atoms. Atoms are the smallest unit of matter that cannot be broken down by chemical means. As what we know of right now, just by ordinary means, the atom can't be broken down. It's made up of protons, neutrons, and electrons. Now, this probably doesn't sound new to you. I'm certain that you've heard it before, but let's do a little brush up here. Protons have a positive charge. That's an easy way to remember it. Protons, positive, they both begin with the P. Neutrons are neutral. They have no charge. They both begin with an N. And the electrons have a negative charge, and there's really no other way to remember it except to remember it. Okay, so here's a diagram kind of showing you where everything resides. Here in the nucleus is the protons and the neutrons. So together, the protons and neutrons make up the nucleus. And then outside of the nucleus, we have the electrons in what are called shells. They're also called orbitals. You'll hear them called valence shells, or so a lot of different names that they're called, but that's where the electrons are, outside of the nucleus, floating around in an orbital. All right, so to know a little bit about these, in order for an atom to be stable or happy, then it would have 2 electrons in its outer shell. In its next outer shell, it would have 8, and the next one would have 8. So however number of electrons are in the outer shell, if that shell is full, we say that the atom is happy, or it's stable. It's unreactive. If it has 8 in there, then it's good. If it doesn't, then it's either looking to get another electron, or it's looking to share another electron. And so we're going to take a look at those coming up. Here we go. Let's first cover element versus compound. An element is one kind of an atom, and then a compound is 2 or more different elements. Remember when we looked at the compound light microscope? And part of the reason why it was called a compound light microscope is because 2 different lenses work together. That was the ocular lens and the objective lens. Well, here we have 2 different elements, and that's called a compound. So if we were talking about carbon dioxide, 1 atom of carbon, 2 molecules of oxygen, because we have carbon and oxygen together, that would be a compound because it has 2 different elements. All right, some basic things you need to know about the periodic table. This side of the periodic table typically has a positive charge, and you'll understand charges in a moment. This side typically has a negative charge. And we'll learn all kinds of different things about the periodic table. But one thing you need to know is this number here, this 1 and this 3 and 4, this number right here is associated with that element. So a 5 is associated with boron here. A 6 is associated with carbon. And that tells us the number of protons that this element has. By knowing the number of protons, we know the number of electrons in a neutral atom because they're the same. Protons are going to equal the electrons, okay? So hang on to that, store that, and then we're going to talk more about that in a moment. All right, so like we said back here, here's hydrogen. It's got 1 proton, which also means it has how many electrons? Yep, it's got 1 electron in it. So let's go over here. Okay, so remember we said that the first shell, that if it has 2 electrons in it, then it's happy. Well, look at hydrogen over here. Hydrogen only has 1 because it's only got 1 proton, so it has 1 electron. And is it happy with 1? Can you have a party with just 1 person? Well, I probably could find a way. But You know, if someone said, hey, who came to your party? And I said, hey, it was me. People look at me a little strange, all right? So it is going to want to share. Here's a hydrogen with one, here's a hydrogen with one. Well, neither one of them are real happy because they're by themselves. So, hey, let's share. Look at like here in the hug, they're hugging. All right, no hugging in class. All right, so here we go. We have got those sharing of electrons going on there. Now, is this one happy? Yep, it's got two in its outer shell. Is this one happy? Yep, it's got two in its outer shell. So everyone's happy. Here we have oxygen, two oxygens together, and they are sharing their electrons in that outer shell there. And so this oxygen's happy now, and this one is, because they both now have 8 in their outer shell. All right, so that's covalent. You're sharing electrons. Another type of bonding, very, very important type of bonding. It's called a hydrogen bond. And water is this magical substance. And it's magical because it has all these awesome, awesome properties to it. And a lot of those are attributed to the fact that you have this hydrogen bonding that occurs within the water molecule. It says it occurs between polar molecules. I want you to think about the poles. Think about the North and South Pole. Where are they located? They're opposite each other. They're on complete opposite ends of the world. Think about the poles on a magnet. We talk about the magnetic poles. You have a positive side and a negative side. Well, that's what we're talking about here. In a polar molecule, you have a slightly positive charge and a slightly negative charge. And so because they have these opposite charges, those charges will attract to one another. So here you have a water molecule. All right, so here's an oxygen and 2 hydrogens. It looks like Mickey Mouse, doesn't it? Yeah, if we drew a little face on there, little Mickey. And these hydrogens are set up that way because they are, because of the polarity. So you can see the attraction here, the hydrogen bond that occurs, the oxygen has a slightly negative charge, the hydrogen has a slightly positive charge, and so they're going to be drawn to each other here. And you can see it with every one of these: oxygen, hydrogen, hydrogen, oxygen, hydrogen, oxygen. So any place where there's an oxygen, there's a hydrogen bonding to it because it's always looking for an opposite match there. All right, so hydrogen bonding, we had covalent, hydrogen, and now we're moving on to ionic. Ionic bonding, gaining or losing an electron. Remember, the goal is to keep this outer shell happy, keep it stable. First shell, we have 2 electrons. Next shell, we have 8 electrons. The next shell, we should have 8 electrons if it was going to be happy. In the case of ionic bonding, okay, let me try that again. In the case of ionic bonding, we're going to donate or accept another electron. All right, let's look at how we actually come up with the number of electrons. Okay, sodium, remember we said that the number of protons equals the number of electrons. Well, sodium has 11 protons. So with 11 protons, that means that it's going to have how many electrons? That's right, it's going to have 11. So we're going to start with sodium and we're going to fill up this first shell. And so our first shell, it's happy with 2. So 1, 2 electrons in its outer shell. In its first shell. In the next shell, it's happy with 8. And there are 8 in this next shell. So far we've used 2 plus 8. So we've used 10 of our 11 electrons. That leaves us 1 more. So we start filling up the next shell, and there's 1 in that shell. Okay, is it happy with 1? No, it is not happy with 1 in its outer shell. Let's look over here at chlorine. Chlorine has an atomic number, which means the number of protons. It has 17 number of protons. Well, 17, we fill up 2, 8, that's 10, that leaves us 7 more electrons. Well, It wants to have 8 out there and it doesn't have 8. So it's not happy. It's not happy. So what's going to happen is this one, sodium's not happy, chlorine's not happy. So sodium is going to say, hey, why don't you take my electron, and you take, and I'll happily, chlorine would happily take it. And so it's going to donate that electron. All right, quick preview here. Ionic bonding is going to donate or accept an electron. Covalent, you're sharing. And then polar covalent, we have the slight positive and slight negative charges. All right, I am going to show you this video in class. If you want to watch it now, it's great. I'm telling you, it's an awesome little video clip. So otherwise, we'll watch it there so that you get a cute little visual. That's all we have today on our atoms and bonding.